Hello, everybody. This is Faisal, co-founder and CEO of Movellus, and today I'm going to share with you how Movellus's application-optimized clocking solutions help our customers improve their overall system-level performance. So before I get into the discussion, here's a quick overview of what I'll be covering. After initial corporate overview, we'll look at why is it that now we need application-optimized IP and what does it take to deliver that. Of course, our technology is part of how we deliver that. And then we'll look at a few customer case studies. And finally, we'll get very specific how we add value to the entire system for our customers. So starting off with our corporate overview, as I've already mentioned, we provide comprehensive application-optimized clocking solutions for SoCs. The company was founded in 2014 in Ann Arbor, Michigan. We have 3 offices, first in San Jose, California, second one in Ann Arbor, Michigan, and then finally one in Toronto, Canada. We are an innovation-driven company. We have 21 patents, 11 granted and 10 pending. The technology was built with over a decade of research. The roots of the technology go all the way back to MIT as well as University of Michigan. And just to share, the core technology is the ability to deliver analog blocks using completely digital standard cells, as well as synthesis and place and route. We've had cross-foundry success. Some of the foundries where we've been successful, TSMC, Global Foundries, UMC, Fujitsu, and many others. And we have a 100% first silicon success record. As far as the customer is concerned, we are in several markets ranging from cloud computing, high-performance SoCs, all the way to ultra-low power energy harvesting IoT SoCs. As far as funding is concerned, we're pretty lucky to have strong support of industry heavyweights. Intel Capital has invested in us 3 times over. And also Stata Ventures, which is a venture fund founded by the founder of Analog Devices, Ray Stata, led our Series A. So why do we need application-optimized IP? So first of all, there's several trends that are happening, macro trends that are happening in the market right now. First, every system and software company has realized that closely optimizing software as well as hardware is a really amazing way of achieving unprecedented efficiency. Apple proved it with iPhone. Now Google, Amazon, Microsoft, Facebook are all co-optimizing their silicon along very closely with their software algorithms. Now, in order to serve that need, foundries have started diversifying the flavors of the process nodes that they release. It is very common to have 5 different process flavors in every single process node. For example, there could be one to address the needs of automotive market, another one for IoT market, another one for high performance compute market in every single node. Now that puts pressure on the IP ecosystem, especially analog IP. And because the end customers are trying to optimize their entire design flow, off-the-shelf and one-size-fits-all IP is no longer appropriate for these applications. So therefore, there's a need for application-optimized IP and efficiency in this design process. So what does it take to deliver an application-optimized IP, specifically analog IP? First, you need automation and process portability. Without that, you cannot meet the demands of the schedules. You also need innovative architectures that remove some of the traditional analog dependencies, such as matching and need for bias currents and bias voltages, as well as special masks. Without removing the needs of these special requirements that are given in a traditional analog approach, the scalability and the flexibility is simply not there. In addition, you also want to remove the voltage headroom limitations because you would have customers that, some customers that want to run an SoC at half a volt supply and a different customer that wants to run the SoC at 1 volt supply. So you need the flexibility and remove the need for having a high voltage in order to provide analog circuits sufficient headroom. And then finally, you want the IP to be correct by construction, as well as you want design time optimization. Configuration is great. However, by definition, when you build a piece of IP that you then count on configuring and reconfiguring in silicon, you're leaving a lot of performance and power at the table there that could be further optimized. So these are all the issues that Movellus's technology addresses. Now let's take a look at a closer look at our technology. So our technology has 3 prongs. First, innovative architectures, then software algorithms, digital algorithms, and then finally methodology. So starting off with architectures and algorithms, This is to demonstrate the power of our architectures and algorithms. We have patented architectures for oscillators. For example, this is a tuning curve of an oscillator that goes from 1.5 gigahertz all the way to 12 plus gigahertz. If you know anything about PLLs, you know that it's a really wide tuning curve. So our patented architecture allows us to break the resolution power trade-off and therefore deliver a really wide tuning range, which then helps us reduce power and area of the entire IP. In addition to that, if you know anything about analog and feedback loops, you know that you want consistent gain across really wide operating ranges. And our digital algorithms allow us to linearize this curve across a really wide operating range, and therefore it ensures that our performance is consistent across PVT corners as well as from part to part. So the final part of our technology, in addition to architectures and algorithms, is the methodology. And here you can see that on the left enumerates the different steps of our methodology, which is exactly the same as visual methodology. We go from algorithm all the way up to physical implementation, time enclosure, as well as reliability, all in the digital design flow. On the right here, it shows graphic representation of what the flow looks like. But I also want to mention that traditional analog blocks typically have feedback loops, which is not amenable for digital design flow. So we have innovation that sits on top of synthesis, place, and route and SDA tools, which allow us to now drive these tools in such a way that they're amenable to feedback loops and other analog type quantities. So to reiterate, our technology is made up of three parts: our architectures, our algorithms, as well as methodology, and that's what allows us to address the need of application optimized IP that the current market is asking for. So continuing on, I briefly alluded to this already. We provide comprehensive total clocking solutions that help our customers optimize their entire SoC. So our goal is to enable SoC level architectural improvements by providing our solutions. So what does that look like? We work really closely with our the chip architects of our customers. We understand their needs, and we deliver exactly the right kind of customized and application optimized PLL and DLL and other timing circuits that enable our customers to really take a comprehensive look at their entire clocking system and optimize the entire SoC. So now I want to take a look at a few customer case studies that will show you how application optimized IP delivers very powerful PPA numbers, as well as help our customers go into push the performance into areas where it's not possible without it. So let's start off with our first case study. It's a multi-gigahertz high performance SoC for AI, cloud AI. And in this particular case, a customer wanted to do really extreme dynamic voltage and frequency scaling from 0.5 volts all the way up to 0.93 volts. And as you know, it's really tough to actually deliver high performance analog in that range. Our architectures and our methodology is able to deliver that design. And as a result of this customer was able to move complexity from data path to clocking. And as a result, really push the throughput of their entire design that much forward. The next case study is about 100 megahertz SoC in voice control AI. One of the issues that this customer had was is a brand new process and a very tight timeline. We were able to deliver a power optimized PLL in a really rapid timeline in 7 weeks, from starting from a brand new PDK to delivering a design, and this design is back in silicon, is working. Another challenge that this customer had was they wanted to operate their SoC at a few different voltage bins because of the different market segments that they're targeting, and we were able to deliver a clocking solution to them that was amenable for all the voltage bins. And then finally, the other end of the spectrum is a really low power SoC. This is an energy harvesting SoC in the industrial IoT market. The entire SoC ran at a really low voltage, and this design is in production. And so we delivered a really low power 700 nanowatt PLL. In this application, every single nanowatt counts because it's an energy harvesting SoC. And we delivered a 0.5 volt PLL for the best power performance and area combination. Slow analog is typically very large, and we were able to deliver the smallest, hundreds of times smaller than any alternatives available to this customer. So we're able to meet their needs not only in terms of power, but also low voltage operation, but also we delivered the smallest area possible. So looking at a few different examples of silicon. So this is selected examples. These designs are on our low power offerings. I want to point out a couple things here. So you can see that we can cover really wide input and output frequency ranges. So really slow frequencies, 8 kilohertz, we can cover that. One thing about PLLs is that typically your loop filter becomes really large if you run at low frequencies. However, that is not the case for us. We can optimize the area as well as frequency ranges. So these are our low power selection and some of the selected silicon in IoT and audio type designs. Now, the other end of the spectrum is high performance PLLs and timing circuits. Here's a couple of examples, 7 nanometer, 10 nanometer designs, multi-gigahertz up to 6 gigahertz with sub-picosecond RMS jitter. I also want to point out that because of our flexibility and customizability, our customers really get an a la carte option. They can really pick and choose what kind of features they want to build in. If the desire is to simplify the PLLs and really have the most power and area efficient design, you can do that. We can deliver very efficient integer-N PLLs smaller than 50 by 50 micron. Or if some of the features in the PLL help your entire SoC, our customers can build in some of the features such as really wide fractional division, multiple phases, multiple dividers, in order to make sure that our customers have exactly what they need for their entire SoC. So we are in ever-expanding markets. So currently we're in several IoT markets, cloud AI, aerospace markets, and FPGA markets, and also we have multiple customers in the edge AI market. So our customer base and the target markets are expanding on a daily basis, and we're really fortunate to have supporting customers who see our value for technology and are taking advantage of that. So the next, I'm going to look at specifically at how application optimized solutions affect the entire SoC. So first, I'll look at it from power, performance, and area perspective. First of all, as I mentioned already, currently with off-the-shelf, prior to Movellus, with off-the-shelf IP, customers would often have to adjust their SoC or optimize or customize their SoC to fit that IP. Now, that's no longer the case. Now we can actually optimize the IP so that it fits the customer's SoC instead of the other way around, and that's how it should be. The other things that we do is we remove extra costs by removing the need for extra supplies, enabling low voltage operation where it's needed. It really actually simplifies our customers' life, and then they really appreciate it. Another really important point that I want to mention here is most SoCs today have multiple modes, such as sleep, standby, and mission, for example. What happens with traditional off-the-shelf IP is that you use your mission mode because your options are limited. You use your mission mode IP often in sleep and standby mode, and sometimes that can become a very dominant consumer of power in sleep and standby mode if you're using your high-speed mission mode IP. With us, with Movellus Technology, our customers are individually optimizing each of their modes. So now you can have a sleep mode, a low frequency PLL that burns very minimal power and keeps your chip alive. And then you can also have a mission mode PLL that runs multi-gigahertz if need be. The next aspect that I want to look at is reliability and testability. Our completely digital designs are fully scannable, so they're DFD enabled. So if you care about risk and fault coverage of SoC, which all of our customers do, now you can optimize. Now you can scan the entire PLL as well, which is not possible with traditional analog PLLs, which are typically black boxed. Not only that, because of our all digital architectures, if you want to design for extreme environments such as aerospace, where you really have to be careful with software and you have to have radiation hardened designs, all you do is you simply point to a different standard cell library and you have your design that is amenable for extreme environments. The next aspect, in addition to power, performance, area, and cost, is the schedule. So often when a customer starts the definition of their SoCs, not everything is finalized, not all the specs are finalized. With our application optimized solution, and thanks to our technology, we're able to evolve along with the customer. So for example, if a customer hopes to close a chip at 2 gigahertz, but then for some reason they think that they can actually run faster, they can come to us and we can adjust the speed of the PLLs. Again, still optimized. So this is not a general purpose PLL; it's optimized PLL for the customer, and we can help them help the IP evolve along with the customer. In addition to that, and these are real cases that have happened with our customers, sometimes PDKs change over the course of the project, as well as because of cost reasons, customer may decide to change their metal stack. And if you're going with a traditional off-the-shelf IP, it's really tough for you to absorb these changes. However, with our technology, we're able to deliver and update the optimization as well as the designs and deliver to the customers without affecting their schedule. So it's really important for us to deliver the best possible solution to our customer without affecting their schedule, as well as have the highest possible reliability and testability. So it's best of all worlds. So finally, last but not least, I want to take a look at what our customers say. So customer support and customer focus is a really important core value to me. It's a really important core value to our team. And here's a couple of quotes from our customers. And because we work really closely with them, they really value the support that we provide. We always work like an extension of our customers' team on a mission, on a project together, and our customers recognize the value that we deliver. With that, I'm going to wrap it up. Please get in touch with us at www.movellus.com or send us an email at sales@movellus.com. Thank you.